Now, an interesting concept occurs when, maybe I have multiple team members that are all working on the same thing. Or more to the point, um, depending on how the organization has structured itself, you might have one central repo and a bunch of people with their own little forks. And each of the people can't talk to each other, but everybody can talk to the main repo. In that case, what you might want to do in order to say you're working in your own little local copy, and suddenly what's happened in the parent repository has changed. What we can do is we can actually just go ahead and add a remote. And I want you to remember that where we are right now, as far as anybody is concerned, is we're at the exact same copy of everything that we've been doing so far. In all of the other tutorials, it wouldn't matter what computer we're on or where inside of a hard drive we might be working off of inside of a mainframe. And what we can do is we can now add another remote. And in this case, what we're going to do is you can note here that this branch Git2, we're 7 commits ahead, but we're 18 commits behind the main repository for the main repo for mixtures. And we need to take these 18 commits that already exist here and pull them in. So that way, when we want to take these new files we've added and actually push it out later, everything goes more or less smoothly. So what we're going to do is we're going to add that remote, git remote -v. Going to add it. We're going to fetch. Always remember to fetch that extra info that's been occurring upstream is what it's called. And we want to name it main. We'll name it main mixtures, right? And it's located here. You should have read access, if not write access, to all of these repositories, to this repository in particular. And of course, those permissions are managed by GitHub itself. So let's go ahead and use our git diff tool. Well, first we're going to clear this screen. You can see all of these other branches that are there, and that's great. And let's double check what branch we're on. Okay, wonderful. And we want to incorporate everything from this main mixtures named repository into our current branch that we're doing right now before we take it all and we actually start to move it further and further up the stream. And what we are going to do, so we'll clear this real quick, and for safekeeping, of course, you can always do git push -u to say your upstream from your fork, and maybe we want to move that new files branch into somewhere remotely stored where it's this kind of time capsule of those files that we're trying to pull in easier. And this makes it simpler to deal with over just taking the files, highlighting them, and dragging and dropping them into the GitHub interface. There's a lot of issues that can occur, and it becomes difficult to actually go back to a point in history where it's just those files and you can kind of work with them as needed. When we put everything into a new branch, we're retaining the ability to take these new files and save them somewhere remotely and keep them nice and separated from everything else. So that way, if something goes horribly wrong in the main area, you still have a state that you can work back off of if you need to. And I mean, it is version control after all. We're controlling and managing the versions of all this crap. Of all this stuff. Because it's not crap, it's great work. So, let's go ahead and save these for giggles. Just so we have something to work off of later if we absolutely have to. And once again, this just creates a new branch on our remote that saves these in a nice little time capsule. Now what I want to do is I want to make sure I'm in this Git2 branch where I've actually pulled everything from, and it's 18 behind the main, and we have 7 new commits that kind of add all this new information in. For paranoia's sake, I'm going to call a git fetch, which takes everything from all remotes and pulls it in just so we can keep track of it. So we're keeping track in this local copy of everything that needs to go on. From here, what we're going to do is we're going to git checkout -b the big main branch, just to make sure that we're always up to date. And we're going to do it from our main mixtures named remote. And the main branch there is named master. And now, of course, we're in big main. And we want, the way I like to do this is I like to switch over first into the branch, the local branch that I know that I'll be merging into. It helps keep track of which things go where a little bit. And I want to git merge big main, which will take everything from big main and bring it into big2, the git2 branch that we've made, and in particular update from upstream information from upstream main branch. So it's created all of these things. It's done some diffs to help us out. And now we can take a look at our git log and say, oh, well, there's all of that. Something we could have done before this, just to double check and make sure that there's no big conflicts, is there's git diff. Actually, let's make sure what I'm talking about here. Oh, okay, cool. So there's git diff, and we could say we want the differences between big main and git toot 3. And it'll tell us more or less every single line by line difference of everything that's there. Press Q to exit. And of course there was, well, let's say I actually revert all of these things. Git revert head let's double check what branch we're on. We're on git toot, git log -n3. I only want the first three. Let's say I actually want to go back to what was here. Actually, it's git reset --hard. And we always know what branch you're in before you do something like this. Because otherwise you can erase months worth of work. I have done it before. Some of this stuff, you know, you just got to be careful. But remember, we're working on our local copy. As long as it's saved somewhere else and you don't git push those changes out to your remote repo or repository, then at least it's saved somewhere. We can go back and rebuild if we make a really big mistake. We want to git reset --hard to this commit. Ta-da! And if we double check, we can git diff. So the whole original point of this is that we can do git diff of our local git toot and whatever big main was, and it'll tell us more or less what the issues are. And we'll get to it later, but there's also a tool called git merge tool, different video. Oh boy, okay. So now that we're here, let's actually go back and remerge everything. Git big main, update to main version, since we're behind. All right, and of course we can now git push. And now that we've done that, let's go back over to our fork, and we can see that everything inside of git2 has now been updated to incorporate everything that was going on inside of the main repo. From there, let's double check our time. Oh, we're at 23. So from there, you know, I have everything more or less set up so that I can be working locally. But what if I don't want to wait for a change to be made? And if this is the main repo and this is my little local, this is my fork that I'm working off of, and off of my fork I have a bunch of little local copies that are going on at this middle level below the main repo for everybody. What if one of my team members is working on something inside of their branch and I actually want access to some of those changes? Well, we've more or less covered the tools that we need, and this way their commits are going to be the exact same by their unique identifier as when they'll go to the main repo, and we'll be working off of some of their information first, right? There are some dependencies here that you have to keep track of, and things can break if it's something more complex than just saying, oh, they wrote this file, I want that file, and I'm going to call it from one of my scripts inside of my own fork. Thankfully, Jordan has opened up his repository and given me access. And what I can actually do here let's say there's this code review branch, and or there's someone else has a copy of older code that I want to go back to, and maybe it doesn't exist inside of the main repo and it's kind of off over in another segment of the team, but I still want access to their scripts. Or maybe I've been tasked with actually taking all of these different pieces and making them all glue together, and that will be my submission to the big main repository. What I can do is, after you've granted someone access to their copy, their fork, is I'll show you here. Inside of your own fork, if you want to give someone access, you can go into settings, and you can manage access. And you can invite a collaborator, especially those who already have a fork of everything else that's there, to have access to your fork. Actually, it looks like everybody might have default access. Let's go double check that. All right, Greg, I'm gonna check out your repository real quick. So you don't actually necessarily even have to make a fork of somebody else's. If you already have access. Oh, okay. No, so it turns out you totally need to give access and invite collaborators to have access to your fork specifically. Once you have that, though, you can go ahead and just add their code as a remote. So we'll add yet another remote. Git remote verbose add -fetch this, and we want to name this Jordan. And let's say that I want to let's go ahead and list our branches again. As you can see, it can get a little complicated. You can remove some of these branches, and of course, as we saw in the help, you can just specify a single branch from that remote to actually go grab, instead of pulling in all of them at once. But let's say that Jordan had some work that was going on inside of one of these branches. Tags. Oh, you were working off your master branch. Right. So let's go ahead and take a look here inside of the master branch. And let's say I wanted to actually go back to this commit here. And this was a little while ago, but I wanted the version of the code that Jordan had before this. And this is just a really roundabout way. This is all assuming that all of this code hasn't actually already been merged into the main repo. of course, all of this particular work has already been merged, so I already have a copy of it. But we're pretending that isn't the case for now. And I want, we'll copy this from this point in history in the ledger, let's say, and I want, and this could be on any specific branch that Jordan made. If he created a new branch and was doing work inside of that first, then I would be able to go to that branch and check out specific commits once I have access. So I want to check out into a new branch. We'll call it Jordan's unmerged feature, and we'll do it from Jordan master from this specific commit. Or better yet, we can just create a new branch from that branch located at that remote, and we can git log, and I want to go to this commit. Sometimes you just gotta look at the help. Since we're already inside of this branch, and this branch is separate from everything else that we have going on, it won't affect anything else that's going on. We can do this. We can set our head to that commit. And once again, be very, very careful about this. It's easy to lose track of what you do or don't have going on. It's always just better to create a new branch, create a new copy. You can prune the branch away as soon as you don't need it anymore. And now I might want to take that code as it currently exists from there and switch back over to my Git where I'm developing a feature. Once again, this could be any old name of a branch, and I could git merge Jordan's unmerged feature after its head has already been reset. So it says we're already up to date because, of course, the actual code inside of Jordan's unmerged feature was already there, and it was in the main master branch. But the neat thing is that people in different forks of the same repository can create these branches and then reference each other as remotes in order to update and share code without doing file duplication across the entire thing. And more or less, it just as what happened here, the same unique ID is attached to each commit inside of the ledgers. And once those match, after you cross-reference the remotes, you end up with the ability to take code that someone's working on that isn't ready to go into the big main branch yet, and still use it within your own code. So that pretty exhaustively covers what's going on here. And just for giggles, let's check the time. Just for giggles, we're going to also create a new remote that's somewhere else on the disk, just because we can. So in earlier examples, we already cloned this separate version over here. Let's go ahead and cd into there. And you'll note that this is actually behind what we had originally. So in a separate directory with a different .git directory, we created these three branches. And now I might actually want to say, here, we'll split this into two terminals to make it a little bit easier. Oh, that's not easier on the eyes. That one's easier on the eyes. Okay. And let's say I actually go to example 2 no git, where we've done all of our most recent work. I can then actually go back and add a new remote, even though this is in a different directory entirely. It could be in a different users directory if I'm on the same mainframe, aka the Jupyter Hub. It could be off of a flash drive, or it could be even a remote connection that you have set up through SSH. So that way you only need to VPN and you just reference the file location of wherever you've done the mount point for the StatHub server, let's say, and you only need to reference it as a file. So what I can do is I can actually add a new remote. Dash fetch in let's test and see if relative paths work here. You can either use, well, first we have to name it, and we'll say we'll call this remote somewhere else, and its location is going to be up1 directory and example1, example2 no git, and we want the .git directory that's actually there. This one. Because when you actually go and look inside of that, it keeps track of where everything actually is. So I want to add a remote inside of this directory of this other directory. And we fetched it, and you can see that we now have all of these other branches that were there, even though we've never pushed them to go be stored on GitHub. And in particular, imagine I'm on the Jupyter Hub and everybody kind of has their one central copy of their fork that exists in their work directory. And under current team, or like team members, current team, yada, 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 where everyone kind of pseudo collaborates on this code, imagine if I just, inside of my own work directory, added a remote to one of those other locations in case I needed to. So that way I could work on things inside of my own directory and only ever push out to that other, to the common shared directory, things that I knew were working and fine and good to go and cleaned up. Or let's say multiple people are working on the same Jupyter Hub instance and nobody has a big shared area. It's been wiped away somehow, but people still have all their code inside of their local work directory. You can just reference each other's work directory in order to make that happen. And of course, I can't VPN in right now, which is part of the reason we're doing all of this, to show you that, but it is possible. And some of the implications are, you don't have copies floating around everywhere of everything. Of course, I have write permission to all of these. And what I can do is let's say in Imagination Land, this is actually our shared directory, and someone, let's see where we are. Let's say and this is my work directory on Jupyter Hub. I can make a copy of a branch that already exists in this other directory, which could also be an SSH connection to a network shared drive or something. Who knows? The possibilities are really kind of endless with this. I can create a local copy that I'm going to name Git2 or shared Git2. And I want it to come from what I've just named as somewhere else Git2. And hey, maybe I have some files in my local directory that I actually want to push out to the shared directory. Makes it a little bit simpler sometimes. Now from here, let's say I actually I do some lorem ipsum. Give me that lipsum. Okay. I add a whole bunch of new text. And I git commit -am, I'm just adding a file that's already tracked with the message added lorem. And I don't even want to git push that. This is the shared one. Maybe it has no upstream area. It's just a common work area for everybody. And over here, I actually go back and I can, let's clear this up a little bit. I do git diff somewhere else Git2. I want to diff Git2 with my local copy that I've named shared Git2. All right, so I git diff my current local working copy in my own little work directory, not the shared one. And I want to check what's happening in the shared directory. I might need to get fetch first. Ah, yes. So as soon as I update this my local work directory example, I have to update first, and then it pulls in the new information, and I can git diff the 2, and ta-da, look, someone else has edited the shared copy, and now I want to update my local copy with git pull. Now in my local copy, let's take a look at file 1. Ta-da. Okay. So that should just about cover it for anything that could possibly be done with a remote, not accounting for potential merge conflicts.